Mind you that for more Microsoft webcasts, you can go to Microsoft.com/webcast. Thanks again for joining us on today's Business Insights webcast. You can't hack yourself secure. It's now my pleasure to introduce your presenter, Jeff Williams, CEO of Aspect Security. Jeff, you have the floor.
Thank you, and thanks to everybody online for taking the time out of your day to attend the webinar. I'm going to take about 45 minutes and then open up the floor to questions. So my name is Jeff Williams. I founded Aspect Security in 2002 to focus exclusively on application security. I love creating tools and standards to help organizations with application security, and you may have enjoyed some of my open source projects like the OWASP Top 10, OWASP WebGoat, the Enterprise Security API, or the Secure Software Contract Annex. Aspect is a proud member of the Microsoft SDL Pro Network, and I'd like to thank them for inviting me to do this webinar. I'd be happy to talk to anybody after the webinar one-on-one. If there's anything I can help you with, please don't hesitate to contact me. So let's jump into it. So the first thing that I'd like to point out is really important, is that you can't do application security the same way you do network security. And the problem is that network security revolves around hardening and patch management. When security researchers identify a vulnerability in a product, a patch gets created along with some signatures for scanners and intrusion detection devices. And once you apply the patch, you're protected. And that process works pretty well. It protects you if you're the buyer of software products and you want to keep your network safe. But when you're building the software, if you're creating your own custom code, then that network security process doesn't work so well. The security researchers aren't going to send you signatures for your web applications. Nobody's out there generating those signatures. So as we'll see shortly, running a web scanner or even doing a pen test on an application simply doesn't generate enough assurance in most cases. If you look at the data breach report from Verizon's, they have an interesting statistic in there. They noticed that of the breaches that they investigated, 381 of them, only 5 of them were the result of patchable vulnerabilities. The other 376 were not patchable, meaning that there was no downloadable patch available. So, that patch management process for what's really causing breaches doesn't really provide much protection. Okay, so what I'm going to talk about today, I'm going to focus on the goal of securing an entire application portfolio. That doesn't necessarily mean that all the applications have to reach some unattainable level of security. The more critical the application is, the more controls and the more verification you'll want. What I want is for you to have visibility into the security of all your applications across your whole organization. So you should have that visibility. You should be keenly aware of what the biggest risks to your entire portfolio are. For example, many organizations don't pay much attention to the security of their internal applications, the ones on their intranet. I think that's unfortunate, because most of the sensitive data and the critical services are on those intranet applications. So even though the likelihood of attack on these internal applications is lower, because there's fewer potential attackers, the impact is potentially considerably higher. So on balance, the risk associated with those internal applications might even be greater than with the external-facing applications. So I want you to get aligned on where you're focusing your efforts. Now, securing an entire application portfolio can be daunting. Many organizations have hundreds or even thousands of applications. And lately, we're seeing applications that are really multiple apps together. So, we just did a review for an application, a financial application, that had a traditional web front end. Then it also had a set of REST web services to provide sort of data layer access. It had an HTML5 front end that could be used on mobile phones or in a real browser, or it also included native mobile applications for Android, iOS, and BlackBerry. So what used to be one application is now fragmenting into a whole bunch of different applications. And our goal is, how do we make sure that all that code is rugged enough to protect your business. Well, Microsoft has an excellent process for this called the Microsoft SDL, the Security Development Lifecycle. And the goal of the SDL is to reduce the number of vulnerabilities and the severity of those vulnerabilities in your software. The SDL has 7 phases, and each one has a small number of practices. The phases are training, requirements, design, implementation, verification, release, and response. And there have been a number of studies that have shown that there's a lot of benefits to implementing an SDL. Forrester concluded that organizations that follow the SDL have better ROI on their software efforts. And the Aberdeen Group found that the SDL reduces the cost of security incidents and also generates a lot more ROI, almost 4 times the ROI compared to other application security approaches. We found the same thing at Aspect. We've helped several dozen large organizations build out their SDL, and we've seen that integrating security into the software development lifecycle unlocks innovation. That's the benefit of an SDL that really attracts me, is that by simplifying security for development teams, organizations can be much more confident about deploying new products and services more quickly and innovate with new technologies. So today, what I'm going to focus on is the verification phase. Many organizations are relying almost completely on either automated scanning or manual penetration testing for assurance in their application portfolio. That means they're essentially just building the software and then searching for vulnerabilities at the very end. Now, that's a negative approach. It's very reactive, and it doesn't lead to improvement in the organization around security. And I call this approach hacking yourself secure, and it doesn't work. By contrast, the SDL has what I consider an excellent approach to verification. That's phase 5 here. Their approach is different than the sort of hack yourself secure approach. The focus is on ensuring that security controls are secure in the way that they're designed and the way they're implemented. So the verification is really just a double check that all the other steps were followed in the process and that the running application is actually safe. Now, the first hint of verification is actually in the implementation phase. You'll see at the bottom there, there's static analysis listed. And project teams building code can use static analysis tools on their source code to detect bad coding patterns. Now, I'll talk a little bit more about static in just a couple minutes. But the verification phase has 2 other kinds of scans as well. There's dynamic program analysis. That's running a vulnerability scanner on the running application. And the second one is called fuzz testing, where you're actually, it's a special type of scanning that throws a lot of garbage data at an application in the attempt to make it break. And the last thing in the verification phase that I think is really important is the threat model and attack surface review. What that does is it goes back and makes sure that any changes in the design or implementation as the system evolved through the life cycle, none of them introduced any changes that would introduce any new risks. So you reevaluate that right at the end to make sure you didn't break something. So I mentioned the goal of most organizations is to get verification coverage. We want coverage over our whole portfolio. So what is that? Well, to me, there's really 3 dimensions. The first dimension on the left is what I call vulnerability coverage. That's to get coverage over what you're trying to protect against. On the bottom, there's portfolio coverage. That's coverage across your entire set of applications. And then the last dimension is what I call the level of rigor. That's your level of confidence that an application doesn't have vulnerabilities. It's how deep are you checking. So I'm going to go through these different dimensions a little bit and dig in on what we're talking about for each of these dimensions. I'm going to start with the vulnerability coverage dimension. So to me, the question that you want to ask here is which vulnerabilities should you prioritize? Are you looking for the ones that are easy to find? Or is it the ones that are the easiest to fix? Is it the ones that are the most likely? Or is it the ones that are going to cause the most damage to your business? And personally, I think the right thing to focus on is those vulnerabilities that are really the most important to your business. It's really a combination of likelihood and impact. You might want to consider how easy the problem is to fix, but frankly, to me, I think that's a minor concern. You want to focus on the things that are the biggest risks. And unfortunately, a lot of organizations focus on the vulnerabilities and the threats that are the easiest to find. If you remember that old joke about the guys looking for your keys where the light is best, instead of where he dropped them, that's what we're talking about here. I want to try to give you some strategies for identifying the vulnerabilities that are most important to your business. But first we've got to talk about scanning a little bit, because so many organizations rely on scanning for assurance. In fact, many organizations use automated scanners as their first and only protection against application security problems. The problem is scanners are blind to a lot of really important vulnerabilities that a human adversary could find quite easily. There's a lot of things that scanners can't see. What I'm going to do in this talk is focus in on a particular class of vulnerabilities that I think are incredibly important, but often overlooked. These are the business logic vulnerabilities. So what does that mean? Well, I once had a conversation with a CISO from a major energy company. They were active participants in the energy futures market, and they used a ton of software written by PhD economists to help them understand that market and do well. The CISO's major concern, his primary application security concern, was that there was a flaw in the way that their energy futures strategy had been coded. An attacker with knowledge of their strategy or a way to predict their trades would have a huge advantage in the market. They'd be able to make huge amounts of money and potentially destroy this company's business. Now, no one who doesn't really understand the energy market could possibly find that type of vulnerability. And to me, that's the touchstone of a business logic flaw. If you search on the internet for papers and so on about business logic problems, you'll find some authors that talk about business logic problems, but they're really, the problems that they talk about are really not what I consider a business logic problem. They're examples like account lockout, enforced browsing, and things that a human security reviewer could find with no knowledge of the business at all. Now, sometimes tool vendors like to define everything that they can't cover as a business logic problem. And it's a neat trick because it makes it seem like their tools cover a lot more than they do. You know, everything except for those business logic problems, and you know, those are impossible. So just to help you, to make it clear, I've provided a little tool here to help you diagnose business logic problems in your organization. So here you see that if a vulnerability requires a deep understanding of the business to identify and diagnose, then it's a business logic flaw. If it doesn't require that, then it's not. So, you know, all joking aside, there are a lot of business rules that are very likely not being verified if you're using an automated tool, or even if you're using a human manual reviewer. It can be extremely difficult to figure out what these rules are supposed to be so that a reviewer can't verify them. Now, I want you to have a really clear idea of what tools can do for you, and the National Security Agency can help. Last year, the NSA ran a test, which is pretty interesting, I think. What they did is they created over 13,000, almost 14,000 test cases for static analysis tools. And each test case tests a particular type of vulnerability. And each test case also includes a number of false alarms, code that looks like a vulnerability but is not actually vulnerable. And they ran all of the top static analysis tools in the market against their test suite, and the results were not very encouraging. This is actually their slide, and as you can see, 85% of the test cases weren't properly discriminated by any of the tools. And the next 10% were only discriminated by one of them. So what that means is if you wanted to get any kind of coverage at all, you'd have to get all the tools, and even then you'd be missing 85% of the problem. Now these tools, you can look at the presentation that I've linked here. It's pretty interesting. These test cases are not the hardest possible test cases. In fact, most of them are pretty simple. So the likelihood, they talk about this in their brief, that there's a good likelihood that real-world code would be actually more difficult for tools to understand. I've got another view of the results here. This one includes false alarms, and it breaks it down by area here. So what you can see here is that all the tools combined only flagged at a maximum 30% of any one category. But as you can see, for information leaks here, the gray part is the false alarms. The green part is the actual vulnerabilities, the actual good detections. So, none of these are doing significantly well. And what's interesting here, I think, is that some of the less important areas like information leaks and file handling are the best areas for the tools, but the most important areas for you are almost certainly areas like authentication, access control, encryption, areas like that. And if you look at the results for those, they're not too encouraging. That said, static analysis tools are powerful. The NSA ran these tools right out of the box with no tailoring, and what we found is that if you spend enough time creating custom rules, these static analysis tools can produce some really useful results. Even the SDL, the Microsoft SDL says static code analysis by itself is generally insufficient to replace a manual code review. And it's not surprising, really. I mean, let me describe the problem this way. The U.S. tax code is roughly 50,000 pages. And it's a specialized language with a specific syntax and a lot of business logic. Now imagine that you're a lawyer and someone tasked you with finding loopholes in the tax code. Could you imagine a software tool that you could run on the tax code to find those loopholes? Well, probably not. It's really hard, right? You might run a spell checker, you might run a grammar checker, and it might produce some useful results, but you wouldn't necessarily want to sign a contract just because it had been through simple automated tools like that. So if your strategy is just to use automation for security, you're probably missing some really serious vulnerabilities. Now, I've got some hard news for the application security business, and this isn't comfortable, it's just a fact, is that scanning and penetration testing are about to get a lot harder. We've been doing this kind of work for quite a long time, and I think we've been in sort of a golden age of pen testing for the last 10 years or so. It's been very easy to intercept web traffic and modify it and do security testing on it. But just a few years ago, it started getting harder. It started with AJAX applications that started sending requests much faster than normal applications, making it difficult to intercept and modify. Then we saw a lot of web services that started using more complex authentication and data formats that made our testing more difficult. And you may have seen that with your scanning tools. It's almost impossible to scan, to do a dynamic scan on a web service. Then recently we started to see a lot of serialized objects, and you can see in the slide there's an example of a GWT, it's the Google Web Toolkit. It's a serialized object that's getting passed back and forth between the server and the client. Those data formats are very difficult to modify. You can't just edit them. They're interdependent in a way that basically it requires you to have a tool. And lately we've been seeing a lot of mobile and even WebSocket applications now that are inventing their own protocols and their own new data formats that basically make all of our tools and techniques obsolete. Code review and static analysis are also getting harder for a number of related reasons, like the rise of frameworks and use of annotations and aspect-oriented programming, and there's a number of other reasons. But all this means that we've got to get focused. We've got to get much more efficient at verifying applications. So to me, the way to get more focused is to realize that great verification relies on a great understanding of what's important for an application. This is really the fundamental difference between attempting to hack yourself secure and true verification. So be careful when somebody says that they're doing a scan or a pen test or a code review. They might mean that they're just going to try and hack you secure. That means, just poking a few holes in your application and reporting you a few vulnerabilities. Or they might be doing it right. They might mean that they're going to actually figure out what security controls your application ought to have and then verify that those controls are in place and work correctly and that they're used everywhere they need to be. So just because an organization says they're going to do a white box test doesn't necessarily mean that they're actually verifying you. They might just be hacking you with a few clues. This is essentially the same problem with compliance and checklist kinds of approaches. Generally, they don't produce meaningful assurance because they're generic. If you want to get benefit out of security verification, it needs to be tailored to your threat model and your requirements. Those are going to tell you exactly what controls need to be in place, and then the test can actually verify that those controls are in place and that they're working. So knowing what's important, I think, is the touchstone of great verification. Now, the verification approach in the SDL is right on track with this. The SDL includes a number of different activities. It specifically lists dynamic analysis, some static analysis, and different types of scans. There are also two optional practices: manual penetration testing and manual code review. And I don't want you to underestimate the effectiveness of these practices. Done right, these approaches can be much more cost-effective than tool-based approaches. For example, let's imagine that we're creating a public-facing web application that stores personal information in a database. So SQL injection is a clear risk here, and using parameterized queries is the obvious control. So when we get to the verification stage, how should we verify that that was done everywhere? If you were hacking yourself secure, you might try a scan, and you might try to find instances where someone forgot to use the right type of query. But to me, you ought to use the most cost-effective way to verify the application as thoroughly as possible. And in this case, it's almost certainly code review, or maybe some properly tuned static analysis tool. That way you're actually finding that all the places in the code where queries get done and checking to make sure that they follow the pattern that you've selected. That's much different than the negative approach where you just try to sort of spot check and find a few holes. So I'm not suggesting you always use code review. What I'm suggesting is that you should use the most cost-effective technique for verifying whatever it is you're trying to verify about your application. And the Microsoft SDL encourages this multi-technique approach to verification because it's the most cost-effective. Okay, so now we've talked a little bit about getting good vulnerability coverage. I'm going to turn our attention now to getting coverage across the whole application portfolio. So in this section, what I want to do is I want to try to talk about a math problem with the purely reactive approach to application security. So to really verify an application as we described, it's going to take at least a week of effort. Now, that effort might be spread across the life cycle somewhat. So if you've got a great threat model, you spent some of your time up front building that out to understand what controls need to be in place. You probably also spent some time generating security requirements and maybe even test cases. Those things are, they're really part of the verification effort. They're setting you up for a successful verification. But I think you've got to recognize that, if you really want to verify your application is protected against the things that matter to your business, it's going to take at least a week of effort. So for the next few slides, I want you to imagine a medium to large financial organization with 1,000 applications in their portfolio, both internal and external facing. And I'm assuming the average size of these applications is roughly 50,000 lines of code. that's a pretty large portfolio, and so these numbers end up being pretty large. If you've got a smaller portfolio, the same approach can help you estimate your situation. So if you've got 1,000 apps and you have to spend a week on each one of them, that's going to be $10 million. Now, it might not be all in 1 year. You might have some schedule that spreads that out over a few years, particularly for the legacy applications. So let's try and put this all together. Let's say the average application has 10 vulnerabilities. That's a pretty low estimate. We typically find more than that, but that would be roughly equivalent to 1 vulnerability per 5,000 lines of code, which is also a low estimate. But I'm trying to be conservative with this so you get the real picture. Now, on the left, you see the cost to find those vulnerabilities. That's roughly $1,000 per vulnerability. And then on the right-hand side, you'll see the hidden cost of actually fixing those problems. And that cost can vary quite a bit, but on average, we figure it's about $4,000 a vulnerability when you build in testing and regression and so on. So you end up with a total of $5,000 per vulnerability. I strongly urge you to try and estimate your remediation costs and include them in your analysis, because many organizations spend the bulk of their official security budget on testing and verification activities, but really the majority of the cost related to these vulnerabilities is coming from fixing problems. And I've tried modeling this a whole bunch of different ways, and if you want, I can share some spreadsheets with you. But no matter what you do to optimize the finding cost, it's really the remediation cost that ultimately drives the overall cost of the security program. And it's hidden in a lot of cases because the fixing cost is usually borne by the development teams. It doesn't get tracked as a security budget item. So it's a little misleading when you actually look at what people are spending on security. And actually, we've looked at it a little bit. We've studied with a few of our clients, and we found that the efforts to reduce the cost in the finding part actually end up making the fixing part cost more, because the fixes take longer to perform, and the rate of remediation failures goes up significantly. So I want you to be aware of false economies in skimping on verification. So let's build on that. You can substitute your own numbers here, but I think projecting the cost of finding and fixing the vulnerabilities in your legacy code is an interesting exercise. So what I want you to try is, take your average vulnerability rate per application. You can use your most recent verification efforts as a guide. Like, let's say, take your 2011 verification efforts and figure out, on average, how many vulnerabilities you're generating per app. And then multiply that out across your legacy applications. So that's going to give you a number for your total number of legacy vulnerabilities. Then you can multiply by what your costs are, what you believe your costs are to find and fix. I use $5,000. You can change that if you like, but that's going to give you a rough idea of what your security debt looks like. So then let's look at new development and how that factors in. So far we've been talking about legacy. What we see in most organizations is about 20% of the current code base gets either created or modified each year. So if you've got 1 million lines of code, you're probably going to be looking at another 200,000 lines of code that next year, across the whole code base. So unless you cut the rate that you're introducing vulnerabilities, if we continue at that rate of 10 vulnerabilities per app, we're probably looking at introducing across our 1,000 apps, we're looking at another a significant number of vulnerabilities, maybe even 2,000 vulnerabilities in the next year. That's another potential $10 million in cost. So what I'd like you to do is try to get get your hands around your future budget going forward. Now, I've worked with a number of organizations where the application security group was basically on demand. They didn't have any forecasts or any projections. Whenever a software project said they were ready, they would submit a request, and then the security team would just come in and do their testing. What I want you to do is try to project that forward, and start to schedule your application security work out for the next year and project how much work you really think you're going to have. We've had good success getting organizations organized around this. What we do is we estimate the work around new software projects, so we go talk to development teams and find out their plans and estimate the amount of security work that we're going to have. And then we also mix in all the legacy application work, periodic reviews that are coming around every 2 or 3 years. We schedule those in together, and when you put them together, those two streams of work create a measurable docket that you can plan around. You can create a budget for doing that work. You can resource it. You can create some concrete metrics that can justify your budget for the next year. One thing that's important to remember with regard to fixing problems is that remediation is not always perfect. So our best estimates are that even groups that get pretty good remediation guidance, tailored and specific to their app, have about a 40% failure rate on remediation efforts. The results are much worse when you just give them the generic results from tools. In many cases, the remediation team can't even find the vulnerability in the code. And so it would be nice if there was a way to estimate sort of an overall metric of how well your application security program is doing across the whole portfolio. And I don't think we're to the point where we can get an exact measure on this, but there is a way to get a rough idea. So here's how I figure that out. The first thing I do is calculate how many vulnerabilities are being eliminated from the code base in some time period. So you might look at the last month or the last year. You ought to be able to get that information out of your bug tracking database, where you track the security vulnerabilities that you find. So figure out your rate of fixing vulnerabilities, then figure out the rate that you're introducing vulnerabilities, new vulnerabilities into your code. And again, you ought to be able to project forward the data that you have in your bug tracking database. And if what you're seeing is that you're introducing more vulnerabilities than you're taking out, your overall enterprise is getting worse. I call that ratio V-flow, your vulnerability flow. And if you can imagine V density over time, it's V flow. And what you want to get to is a positive V flow, so that every year you're reducing that security debt and working it off. All right. So I'll sum up this part of getting coverage over your portfolio with a couple of graphics that summarize the different strategies that I've seen organizations follow. So we've got scanning up here in the top left. It's sort of broad and shallow in terms of coverage. Manual analysis, because it's difficult to, it's more time consuming to do manual analysis on apps. It's deep, but you typically only cover a small part of the portfolio. The spend approach can get you, deep coverage across a broad range of apps, but it can be very expensive. And then there's always those organizations that are not going to put much effort into application security. They're just going to pray they don't get attacked. So in a second, I'm going to suggest sort of a combined strategy that takes the best of both worlds. But first, I want to spend just a second and talk about level of rigor. So when you look at any particular application, you want to decide whether the app is protected against a certain level of threat. You want to check to make sure that you've got the right controls in place and that the controls actually work. But how deeply are you verifying that that control is present and actually works? In the ASVS, the Application Security Verification Standard, we suggested a 4-tier system. The lowest level of rigor is just the scan level, where you get some evidence that there might be vulnerabilities, but not really anything beyond that. Manual verification can check to make sure that there's a control present and that the control is correct, like it actually behaves the way it's supposed to. Sometimes manual efforts have trouble verifying that that control is used in all the places where it needs to be used because it's difficult for manual reviewers to get coverage over the entire code base or the entire web app functionality. The next level up, we have architecture level, where you're actually studying the intended security controls and where they fit into the overall system architecture. And the highest level is a review for malicious code, and the sort of deep issues that assume a malicious insider. Those are particularly difficult to verify against. So I want you to understand that there's a range of levels of rigor when you do verification, and you should choose the level of rigor that makes sense for your particular business and your organization. Now, you've heard of Moore's Law. That's the one where computing power doubles every 18 months or 2 years. Well, in security, Josh Corman coined H.D. Moore's Law. Now, H.D. Moore was the creator of Metasploit, and H.D. Moore's Law is that casual attacker power grows at the rate of Metasploit. Now, what that means is that as Metasploit advances, which means essentially the level of script kiddie kinds of attacks, all the automated attacks, that casual attackers get better and better at finding problems. And what it graphically points out is that auditors, people that are auditing against a particular standard like PCI or even the OS Top 10, they're not generating enough assurance even to protect against these casual attackers. Now, when you look at this slide, where do you want to be? The threat is advancing. So, what level of attack do you want to be protected against? Is it casual attackers? Do you want to be protected against chaotic actors like Anonymous and Lulzsec? Or do you want to have to be defended against organized crime, or even up to, nation-state espionage level of attack? You have to decide that, but that drives the level of rigor that you want to invest in your application security program. Okay, so let's try and put all this together a little bit. We'll talk about portfolio verification strategy. So at Aspect, we spent a lot of time on this problem. We've worked with organizations with hundreds or thousands of applications, and we've created a cost-effective strategy to get coverage over a whole portfolio over time. Now, we know that nobody can take on this problem all at once, and so we recognize that you have to have a way to grow this program over time to get to the coverage that you need. And so here I'm showing the coverage area. On the bottom, we've got the whole application portfolio sorted out from more critical apps all the way down to less critical apps. And then on the other dimension, we've got the level of coverage. How many vulnerabilities you're covering and how rigorous are we being about the coverage that we're getting. So we start with establishing some level of automated scan across as much of the portfolio as we can get to. And the reason we do this, we actually take out most of the built-in rules. What we focus on is getting a few rules that are very reliable and focus on a risk that's really serious to the business. So we're not actually using these automated tools exactly the way that their vendors intended. What we're doing is we're trying to start with a focus on the most critical problems without alienating the whole development staff. So we use these technologies to find a class of problems that's important and that we can get really good results from. And we build some, we make some progress that way. And at sort of the same time, we launch and we do a deep review. Aspect does quite a lot of manual code review and manual security testing on critical applications. And what we look for there is we look for vulnerabilities, but really what we're trying to do is we're trying to isolate particular patterns in those applications that for that organization represent a significant problem. So we look for the coding patterns in that organization that are leading to things like access control problems, authentication errors, cross-site scripting, a whole variety of problems. And what we try to do is we take those patterns and we try to build those into the automated platform. So we're not using generic rules here. We're using rules that we've tailored to the particular organization to get a little deeper coverage across the portfolio. And as we build out those patterns, we add to the scan so that our program scales nicely. We also start identifying from all this data that we're collecting. We capture all the data and we start doing some metrics on it. And we try to identify opportunities to create new standard controls for the organization. Those controls target specific issues that the organization is facing on a global scale. And when we deploy those controls, then we can also update the scanning platform to get even a little better coverage. Actually, once you start deploying standard controls, the whole application security problem starts to get a little simpler. And this program together creates this tailored, efficient application security program over time. So just to give you a little example of how this plays out, one financial organization we've been working with for several years has been following this approach, and they've essentially stamped out most of their major application security problems. They started with authentication. That was a particular challenge for them. They had lots of distributed systems. We helped them standardize on a single authentication framework. They've pushed that out across their portfolio. We've tested it extensively, and we just don't find authentication and session management problems there anymore. They've solved that, in my mind. We do occasionally find them in third-party programs that they acquire, but in the stuff that they build, it just doesn't happen. It's the same thing with access control. A little later, they tackled that. They built out a bunch of standard services around access control, and it's very rare when we find an access control problem there. It's only when they're really rolling out a new technology or they're moving to some new framework that we start finding things there. But they get it under control, and they've got sort of a responsible program around that. Same thing with SQL injection. Their mid-tier is well protected against SQL injection, and we've essentially stamped it out. So what we find in organizations that follow this approach is that the vulnerabilities start disappearing from our pen tests and our code reviews. It starts getting a lot harder to do the pen test and code review work to the point where eventually we just, we still look, but we're just not finding those problems. So recently they've turned their attention on cross-site request forgery and cross-site scripting. For cross-site scripting, we did a study, and I've summarized some of the results here. Essentially, we isolated a number of common patterns in their code, in their framework and in their code, that were leading to real XSS in their apps. And we projected those across the code base after estimating how likely it would be for somebody to actually exploit them. And we get this number that suggests which ones we ought to fix first. They chose a few and targeted those. We built automated tools around that, found a number of instances, and the XSS rate at their organization is falling dramatically, which is unusual. Most organizations are really having a lot of trouble with XSS. They're not making much progress against it. And we're trying to do the same thing with CSRF. Actually, there we created a centralized control, integrated into their UI libraries, pushed it out in a log-only mode for several months, and we ran it to make sure that it wouldn't cause any harm. And they've just enabled it, and now they're protected against XSS across a huge range of their applications. So I want you to think about the difference between that kind of program that I'm describing and the hack yourself secure approach. The hack yourself secure approach would have said, well, CSRF, we just found it in application A, and then the next time we find it in application B, and then application C, and every time it would cost a significant amount of money. getting in front of the problem, not doing it one app at a time, but thinking about a portfolio approach can save quite a lot of money across an application security program. So I wanted to challenge you a little bit with a new vulnerability that's emerged recently. Well, it's been around for a little while, but it's really starting to gain a lot of attention. XML Entity Expansion XC. It's relatively underappreciated. What it does is it causes an XML parser to sort of misfire if an attacker supplies an XML file to an application, which happens pretty frequently. The XML parser misfires and includes a file from the hard drive of the attacker's choosing in that input file, and then sometimes that data gets disclosed back to the attacker. So we found a number of instances that allow us to use that flaw to basically scan the whole hard drive on an application server. So I ask you, how, or maybe you should ask yourself, is how big of a problem is this for your organization? It's not really easy to scan for. There's a lot of XML parsers out there. So whenever a new vulnerability like this emerges, you should estimate it. You should get in front of it. Search your code and extrapolate a little bit and get an estimate around it and decide whether it's something that you need to put into your application program and build standard controls around. So that's where your application security program should be, in front of new problems rather than reacting after the vulnerability has already been enshrined in millions of lines of code. All right, so to sum up a little bit, I don't think that trying to continually scale verification programs up is going to work. It's essentially playing whack-a-mole, and eventually the moles are always going to win. We're writing more code, and it's getting harder to do that kind of testing. So what I want you to think about is when you're trying to secure your portfolio, scale down the problem space. Establish standard controls and make it easier on your development teams and on your verification efforts. That's the only way, in my view, that you're really going to be able to get in front of the whole problem. So at the end, I think we'll see eventually that organizations start to what I call build verification in. That as your applications get developed, you build out standard controls and patterns and use those, and then you'll have evidence that those controls are already correct and that they're present in every application. All you have to do is check that they're properly used in your portfolio, and it makes verification considerably simpler. So in summary, I want you to leverage the approach in the Microsoft SDL to get control of application security in your organization. I believe that you'll never make progress with reactive approaches, the ones that I call hacking yourself secure. In this talk, we covered three main themes. We talked about not applying tools in a knee-jerk fashion. You want to understand exactly what you're trying to verify and then choose the most cost-effective approach, even if it's manual. The second thing, try to understand your portfolio's vulnerability flow, and then plan your budget so that you can get in front of that problem and make sure you're making progress over time across both legacy and new code. And then the third thing, if you can't scale up verification, try to scale down the problem space by standardizing and externalizing your security controls. If you do those things, then you'll evolve from, through these stages, from where you are now to when you have a few standard controls, to when you've got a whole suite of standard controls, to eventually where you're ahead of the curve and you're being proactive about application security. I hope this was helpful to you all. Appreciate your time today, and I look forward to hearing from you. My contact information is on the last slide of the deck, which we'll get to in just a second. Thanks.
All right, thank you, Jeff. And ladies and gentlemen, if you do have any questions for Jeff, please go ahead, click on your Q&A menu option at the top of your screen, and you can type your question into the field provided and then click the word ask. Again, please don't click the hand. That's not going to submit your question. You will need to click the word ask. And as Jeff mentioned, here is his contact information. If you'd like to print these slides in a PDF format, you can do so at this time by going to the lower right-hand corner of your client and clicking on that printer icon that will allow you to print or save these locally for your convenience. And finally, appearing in your slide area right now is the portal to the post-event evaluation. We ask that you please take a moment to fill this out before logging off today. Your feedback is very valuable to us, and it will affect future content for Business Insights Webcast. So you can click on either Registered Online or All Other Registrants. They will both take you to the evaluation, and again, we do appreciate your feedback. So with that, I'm going to turn the floor back over to Jeff for any questions that have been submitted or any closing statements.
Okay, great, thanks. So there's a question here that asks about manual code review, and is manual code review worth it? So I'm a strong believer in manual code review, and I just saw a talk about this at the OWASP AppSec DC conference by Dave Wickers, who's one of our folks here at Aspect Security. He talked about the power of using code review to find vulnerabilities and pointed out a lot of situations where tools are not very effective at finding certain vulnerabilities, and code review can be extremely effective. In fact, much faster than even dynamic scans of applications. So it does take a skill set to be able to actually review code, but there's a lot of value in it. So I think it's definitely something that you want to have in your toolbox. Now, I always recommend a combined approach to application security verification. I don't say code review is the right solution for every problem or even for every app. Every time an application is in front of you, you need to choose the most effective way to verify that particular application. Maybe you can scan it, maybe you can't. Maybe you can do pen testing on it, maybe you can't. Maybe you've got the code and you can just check in the code quickly. I encourage you to choose the most cost-effective way of verifying it and not be slave to just one particular approach to verifying applications. All right, well, it looks like that's it on questions. So, again, I thank you all for your time today.
All right, thank you, Jeff. And ladies and gentlemen,